Here we have the initial setup for our Python script. We start by installing the necessary libraries using pip, sentence transformers for text embedding, ChromeAD for efficient data storage and retrieval, Allama for running large language models, Markdown for parsing Markdown files, and PyPDF2 for extracting text from PDF documents. Next, we import the required modules. We bring in ChromeAD and Allama, which are essential for our RAGSystem. We also import the OS module for file path handling, and from the typing module, we import list, dict, and any for type hinting. We then import the Markdown and PyPDF2 modules to handle different file formats. Finally, we import the embedding underscore functions from ChromeAD.utils to use the sentence transformer embedding function for text embedding. Here we have the initialization of our RAGSystem class. We start by creating a ChromaDB client and an embedding function using sentence transformer. We then create a collection with the specified name and embedding function. Next, we define a method to preprocess the text by removing extra whitespace and new lines. This helps to clean up the text before adding it to the database. We also have methods to extract text from Markdown and PDF files. For Markdown, we read the file, convert it to HTML using the Markdown library, and return the HTML content. For PDFs, we use PyPDF2 to read the file page by page and extract the text. Here a file extension from the provided file path. Then, based on the file extension, we call the appropriate method to extract the text from the document. We support Markdown, PDF, and plain text files. After extracting the text, we preprocess it using the _preprocess_text method to remove any extra whitespace and new lines. Next, we ensure that the metadata is a non-empty dictionary. If no metadata is provided, we initialize an empty dictionary. We also add the file path to the metadata. Finally, we add the preprocessed text, metadata, and file path as the document ID to our collection using the add method from the ChromeAD library. Next, we have the search function. This is where we take a user's query and find the most relevant documents in our collection. We pass the query and the desired number of results to the collection's query method. The results we get back include the actual document content, associated metadata, and a distance score indicating how closely each document matches the query. To make this information easier to work with, we repackage it into a list of dictionaries, where each dictionary contains the document text, metadata, and distance score for one result. This search capability allows our system to quickly retrieve relevant information from our knowledge base, which is a key part of implementing Retrieval-Augmented Generation. Here we have the generate_response method. This function takes a query and a context as input and generates a response using the Allama language model. First, we construct a prompt by concatenating the context, query, and a prefix for the answer. Then, we pass this prompt to the Allama model's generate function, along with the specified model, to generate a response. Finally, we extract the actual response from the returned dictionary and send it back to the caller. This allows us to generate a contextual response based on the given query and context. Now, let's focus on the query_n_generate function. This function takes a query string and an optional n_results parameter, which defaults to 5. First, we call the search method to retrieve the top n_results documents that are most relevant to the given query. The search results are stored in the search_results variable. Next, we create a context string by joining the document texts from the search results, separated by new line characters. We print the context to display it for reference. Finally, we call the generate_response method, passing the query and the context. This generates a response based on the provided context, and we return this response to the caller. The query_n_generate function combines the search and generate_response functionalities to provide a convenient way to search for relevant documents and generate a response based on the query and the found context. Here is the script for the scene. This sets up our system, ready for use. We add a document to our system using the add_document method. In this case, we're adding the U.S. Constitution PDF file. With our document added, we create a query string asking for information about Article 2 of the U.S. Constitution. We then pass this query to the query_n_generate method of our RAG object. This method searches through the added documents and generates a response based on the context it finds. Finally, we print out the generated response to see the result.